So, hi, I'm Katharina and I'll give you a short introduction into our work on predicting visual aesthetics. So, if an image is aesthetically pleasing can depend on a variety of different factors. For example, this sunset image together with the geometric forms of the bridge lead to an astonishing composition. Or this image shows an intriguing landscape with wonderful autumn colors and a very harmonic atmosphere. And here, organic geometry and depth of field lead to a very intriguing impression. So the aesthetic appeal of each of these previous pictures actually depends on other factors, and this makes visual aesthetics very complex. But aesthetics is not only very complex, but also very subjective. For example, if we would ask 3 people here to rate the aesthetic appeal of this picture on a scale between 1 and 10, we might end up with 3 different responses. Probably they lie somewhere in the upper half. So overall, there are 2 main challenges when predicting aesthetics: its own complexity and the subjectivity of people. So to tackle the complexity, some previous work has, for example, proposed to rank on a one-dimensional scale or has incorporated handcrafted attributes to cover visual factors. In contrast, we now aim for a rather general approach to automatically map aesthetics with all its complexity into a high-dimensional feature space. Thereby, our aesthetic space allows us to learn a mapping into a very fine-grained resolution in which aesthetic relationships are maintained. Further, to approach the subjectivity between people, we need to learn from a lot of data and incorporate a broad diversity of people. Now, in social online platforms, people can easily like images with a single click. So we make use of this behavior and assemble a large data set which allows us to exploit aesthetic ratings from online data. So let me give you a short overview of our approach. From Flickr images and their according online ratings, we derive an aesthetic model to score the appeal of a picture. Then, we use our aesthetic model to guide the training process of our CNN and learn relative distances in our high-dimensional space. Therefore, we focus on the information if 2 images are aesthetically similar or not, instead of the direct scores. This allows us to consider relations between images even if they do not seem visually comparable. So finally, our trained CNN can output encodings for any arbitrary image, allowing for various applications. Our prototypes comprise resorting personal photo collections, capturing the best shot on mobile devices, and identifying best spots in a video. So here you see some examples of our AROD database. Although both images had a similar number of visitors, the left image received a lot more likes. Thus, the beautiful left image was also scored higher by our aesthetic model. Let me also briefly show you a very interesting outcome of our network. So the question is, what is the information the network is actually looking for? Therefore, we calculated saliency maps to visualize the impact of image regions on the network prediction. We compared the saliency maps for object recognition with our aesthetic model. Let me show you an example. Here you see a beautiful image. And this is the saliency map for ResNet trained on object recognition. The darker regions have a higher impact on the actual network prediction. So we see that ResNet really focuses on the objects. However, now this is the saliency map of our aesthetic model. And you can see how the entire image is considered, and we can find a synergy between large image regions. So, whereas the ResNet focuses on objects, our aesthetic model considers the entire image. Thus, it is necessary to consider global features when dealing with aesthetic tasks. So, finally, I also want to show you one of our applications which finds appealing spots in the video. This application calculates encodings for the whole video stream and creates an aesthetic prediction curve. Now, let's have a look at the video. You can see how the appeal gets weaker when the trees at the border slowly disappear, and it gets higher now for when the scenario is changing of the lake in front of the hills. Okay, so thanks for your attention, and you can find all the data, including links to our database and our model on our project page. Now, if you want to talk about beautiful images, then please come to my poster. Thanks.